Welcome to Space. I bet you didn't know just how much our curiosity about the cosmos has shaped who we are. From the moment we first looked up at the night sky, we have been driven by an insatiable curiosity, a deep-seated need to understand our place in the cosmos. This quest has led us down a path of discovery, pushing the boundaries of what we thought was possible, turning science fiction into scientific fact. We build great machines, not just of metal and wire, but of dreams and ambition, to peer deeper into the void, to listen for the whispers of creation, and to venture forth into the great unknown. It is a journey that defines us as a species, a testament to our relentless spirit of exploration. We stand today at a remarkable precipice in this grand journey. The universe, once a distant and abstract concept, is becoming more tangible with each passing day. Recent breakthroughs, powered by unprecedented technology and international collaboration, are peeling back the layers of cosmic mystery, challenging our long-held assumptions, and revealing a universe far more dynamic and complex than we ever imagined. From the discovery of new worlds orbiting distant stars to audacious experiments that mimic celestial events, we are rewriting the textbooks of astronomy and astrophysics in real time. So I invite you to join me on this voyage. A journey through the latest triumphs and tribulations that mark our path among the stars. We will witness the birth of new knowledge, the fiery tests of our ambitions, and the quiet, steady progress of science. Together, let's explore the events that are shaping our future in space, from the delicate dance of distant planets to the thunderous roar of rockets reaching for the heavens. The cosmos is calling, and we are finally beginning to understand its language. For centuries, we could only dream of worlds beyond our own solar system. They were just ideas, things people talked about. But dreams can come true when people are clever and work hard. The James Webb Space Telescope, a huge golden eye sent to orbit the Sun 1,000,000 miles from Earth, is the result of many years of these dreams. It was made to see things we couldn't before, to catch the faint old light from the very beginning of time, and to look closely at the air around planets far, far away. Now that promise is coming true in an amazing way. Webb has officially found its very first planet outside our solar system, called LHS 475b. This isn't just another tiny light in a sea of information. It's a confirmed world, a place in the huge ocean of space that humans have now mapped. This big step isn't just about technology. It's a huge moment in the story of space, a new part in our search for other places in the universe that might, just might, be like our own. LHS 475b is a rocky planet, almost the exact same size as our Earth. It goes around a red dwarf star, which is the most common kind of star in our galaxy, and it finishes a whole year in just 2 Earth days. Imagine that, a world so close to its sun that its whole year is shorter than our weekend. This closeness means its surface is probably super hot, a few hundred degrees warmer than Earth, so it's probably not a place where life as we know it could exist. But finding it gives us a big hint. The real power of the Webb telescope isn't just in finding these planets, but in understanding them. Using its fancy tools, scientists are now looking through the light that passes through this planet's air. They are looking for the chemical signs of gases, the building blocks of an alien sky. Does it even have an atmosphere? If so, is it thick and heavy like Venus or thin and wispy? Could it be made of pure carbon dioxide or something stranger? These are the questions that Webb was built to answer. Every tiny bit of light collected from LHS 475b is a piece of a puzzle. Looking at this information carefully takes amazing accuracy and patience. The telescope has to stare at the star system for hours, waiting for the tiny dip in light as the planet passes in front of its star. It's in that quick moment that the secrets of its atmosphere are shown. Finding this Earth-sized world is just the start. It proves that Webb can not only do this tricky work, but is really good at it. It has opened a new door, letting us study smaller, rocky planets that we couldn't reach before. Before Webb, we could only study the atmospheres of giant gas planets, which were the easiest ones to look at. But now, we can look into worlds that are truly Earth-like in size. This ability completely changes how we search for planets outside our solar system. It changes the focus from just finding them to really understanding them. We're not just counting planets anymore, we're starting to get to know them. We are making a list of worlds, each with its own special features, its own story told in light and chemicals. It's like taking a huge count of everything in the galaxy, bigger than ever before. The team that found this planet, from the Johns Hopkins University Applied Physics Laboratory, looked over the information with an excitement we can all share. They saw the first hints and information from NASA's TESS satellite and knew they had to point Webb towards this star. It was a risk, a test of what the telescope could do. And it worked out, proving that the hopes and hard work of thousands of scientists and engineers were worth it. What does this mean for the future? It means that in the next few years, we can expect a lot more discoveries like this. Webb will look at many other promising places, rocky worlds in the areas around their stars where it's just right for liquid water to be on their surfaces. Each new observation will add another piece to the big picture of how different planets can be. The search for life beyond Earth is one of the most important things humans have ever tried to do. It answers our deepest questions about being alive and being alone. Are we alone in the universe? Finding LHS 475b doesn't answer that question, not yet. But it's a very important step forward. It proves we have the right tools to look for answers in a scientific way. We are moving from guessing to actually seeing. We are becoming true explorers of the galaxy, not with spaceships, but with light. The tiny bits of light that traveled across 41 light-years to reach Webb's mirror could change how we understand our place in the universe. This is more than just information. It's a message from a far-off place. The story of LHS 475b shows how curious we are. It reminds us that for every question we answer, many more pop up. What other kinds of worlds are out there? What strange and amazing atmospheres will we find? The James Webb Space Telescope is our guide on this journey, and it has just shown us the first of many amazing things it has in store. The universe is huge and full of possibilities. With each new world we find and study, we learn more not just about space, but about the things that made our own planet and us possible. The discovery of Webb's first exoplanet is like a bright light, showing us the way forward in our huge adventure to explore the stars. The Sun. It is the heart of our solar system, the source of all light and life on Earth. Yet for all its brilliance, it holds its secrets close. The Sun's outer atmosphere, the corona, is a realm of ethereal beauty and extreme physics. A wispy halo of plasma, 1,000,000 times fainter than the Sun's surface, it is ordinarily completely invisible, lost in the overwhelming glare of the star it surrounds. To study this enigmatic region, scientists have traditionally relied on a rare and beautiful celestial alignment, a total solar eclipse. For a few precious minutes when the moon perfectly blocks the sun's disk, the ghostly tendrils of the corona are revealed. But these events are fleeting and geographically limited. What if we didn't have to wait for nature to provide the perfect cosmic coincidence? What if we could create our own eclipse, on demand? This is the audacious goal of the European Space Agency's Proba 3 mission. It is a feat of engineering that sounds like science fiction. 2 satellites, flying in perfect formation, separated by 150 meters, to cast a precise shadow in the vacuum of space. One spacecraft, the Occulter, carries a circular disk designed to block the light from the sun's main body. The other, the coronagraph, follows precisely in its shadow. From the perspective of the coronagraph satellite, the Occulter disk perfectly blots out the sun, creating a sustained, high-quality artificial eclipse. This allows its instruments to have a continuous, unobstructed view of the sun's faint corona. It's a celestial ballet, a dance of machines choreographed with millimeter precision, performed 60,000 kilometers above the Earth. Maintaining this formation is an extraordinary challenge, requiring autonomous navigation systems of unprecedented accuracy. Recently, this groundbreaking mission achieved its primary objective. Proba 3 successfully executed its delicate maneuvers and created the first-ever artificial solar eclipse in orbit. For 6 hours at a time, the coronagraph instrument was able to stare into the sun's hidden atmosphere, gathering data of a quality and duration that is simply impossible to obtain from Earth, even during a natural eclipse. This achievement opens up a whole new field of solar physics. Scientists can now study the inner corona, the region where some of the most mysterious and energetic solar phenomena originate. This is the birthplace of the solar wind, the stream of charged particles that flows out from the sun and washes over the entire solar system. It is also where coronal mass ejections, giant eruptions of plasma, are born. Understanding these phenomena is not just an academic exercise. Coronal mass ejections can hurl billions of tons of material into space at incredible speeds. If one of these storms is aimed at Earth, it can have serious consequences. It can disrupt our power grids, damage satellites, and pose a risk to astronauts in orbit. By studying the inner corona with Proba 3, we can better understand the mechanisms that trigger these events and improve our ability to forecast space weather. Spain has played a crucial role in this remarkable mission. Spanish companies and research institutions have been at the forefront of developing the key technologies that make Proba 3 possible. From the optical systems of the coronagraph to the complex software that governs the formation flying, Spanish ingenuity is woven into the very fabric of this project. It is a testament to the nation's growing leadership in the European space sector. The data now streaming back from Proba 3 is a treasure trove for solar physicists. They are seeing the base of the corona with a clarity never before achieved. They can watch as magnetic field lines twist and snap, releasing vast amounts of energy. They can track the flow of plasma as it is heated to millions of degrees and accelerated away from the sun. It's like being able to watch the engine of a storm as it forms. This mission is a perfect example of how we use technology to create new ways of seeing the universe. We couldn't get the view we needed, so we built a machine to make it for us. We built our own miniature moon and put it exactly where we wanted it. This level of control represents a new paradigm in space science, where we are not just passive observers, but active participants in our experiments. The success of Proba 3 will have a lasting impact. It paves the way for future multi-satellite missions that will rely on high-precision formation flying. Imagine fleets of space telescopes flying in formation to create an interferometer the size of a planet, or missions to study distant star systems by having one satellite block the starlight so another can see its planets. Proba 3 is the proof of concept for these future dreams. While the James Webb telescope looks outward to the farthest reaches of the cosmos, Proba 3 looks inward, at the star that governs our own existence. Both missions, in their own way, are pushing the boundaries of observation. They are tools that extend our senses, allowing us to perceive the universe in ways that were once impossible. The ghostly, beautiful light of the corona is no longer a secret kept by the chance alignment of sun and moon. We have pulled back the curtain ourselves. Through the tandem flight of two remarkable satellites, we have created perpetual twilight in a small patch of space, and in that engineered darkness, we are finding brilliant new light. The road to the stars is never a straight line. It's a path, honestly, that's forged through trial and error, paved with both spectacular successes and, well, fiery public failures. Every great leap in space exploration has been preceded by setbacks, by explosions and anomalies that really test the resolve of those who dare to dream of other worlds. The journey to Mars, which is humanity's next great destination, is proving to be no exception. In the dusty expanse of South Texas, at a facility aptly named Starbase, SpaceX is building the machine they believe will take us there. Starship. It's a vehicle of unprecedented scale and ambition, a fully reusable rocket designed to carry, get this, 100 people to the Red Planet. But building the future is frankly a noisy, messy, and often explosive business. This reality was on full display during a recent static fire test. The test was meant to be a routine checkout of the engines on a Starship prototype. The massive rocket was bolted to the launch mount as its engines were ignited for just a few brief seconds, a standard procedure to verify that all systems are ready for flight. But something went terribly wrong. A serious anomaly occurred during the test, leading to a catastrophic failure. The prototype erupted in a massive fireball, sending debris flying and a shockwave across the landscape. Fortunately, the area was cleared and no one was injured in the explosion. This is a core tenet of the SpaceX philosophy: test hardware, not people. But the incident was a dramatic and visceral reminder of the immense power we are trying to tame. The energy contained within these rockets is colossal, and the margins for error are razor thin. The explosion was a setback, a costly and time-consuming one. For SpaceX and its founder, Elon Musk, this is part of the process. Their approach to rocketry is iterative. Build, test, fly, and if it breaks, figure out why and build a better one. They push their hardware to its limits on the ground so that they can find and fix weaknesses before they attempt a full-fledged orbital launch. Each explosion, while visually spectacular, is a source of invaluable data. Engineers are now meticulously combing through the telemetry from the test and the wreckage of the prototype. What was the root cause of the failure? Was it a flaw in an engine turbopump? A leak in a propellant line? A software glitch? Finding the answer is a complex piece of detective work. Every sensor reading, every frame of high-speed video, is a clue that will help them prevent the same failure from happening again. This event highlights the immense challenge of developing a fully reusable super heavy lift launch vehicle. Nothing like Starship has ever been built before. Its stainless steel construction, its 33 methane-fueled Raptor engines, its ambitious landing profile, all of it is uncharted territory. Setbacks are not just possible, they are inevitable. The question is not whether you will fail, but how you learn from it. The explosion will undoubtedly delay the timeline for Starship's first orbital flight test. It pushes back the dream of seeing humans walk on Mars, but it does not extinguish it. For every prototype that is destroyed in a test, another one is already being assembled in the massive high bay nearby. The production line at Starbase is designed for this rapid, iterative cycle of development. This public and sometimes explosive development process is a stark contrast to the more traditional, cautious approach of government space agencies. It is a high-risk, high-reward strategy. The failures are more visible, but the potential pace of progress is also much faster. It's a philosophy born in the fast-moving world of software development, now applied to the unforgiving physics of rocketry. The sight of a massive rocket exploding is a powerful one. It can be seen as a failure, a symbol of overreach, but it can also be seen as something else, the physical manifestation of ambition. It is the price of pushing the envelope, of refusing to accept the limitations of the past. It is the fire in which the future of spaceflight is being forged. The dream of Mars is a powerful motivator. It's what drives the teams at Starbase to work around the clock, to analyze the wreckage, and to start again. They know that the vehicle they are building is not just a machine of steel and fire, but a vessel for humanity's future. It carries the hope of becoming a multi-planetary species, a hedge against the existential risks we face on our home world. So while the explosion in Texas might look like a step backward, in the grand narrative of our journey to Mars, it is simply part of the story. It's a lesson learned the hard way, a scar that will make the final vehicle stronger and more reliable. The path to the red planet is littered with the ghosts of failed prototypes, each one a stepping stone towards the ultimate goal. The fire and smoke have cleared over South Texas, but the ambition remains. The work continues, fueled by a vision of red dust and new horizons. The explosion was not the end of a dream, but a violent and necessary chapter in the epic tale of how humanity will one day reach for another world. While some rockets meet a fiery end on the test stand, others soar magnificently into the heavens, carrying humans and their scientific ambitions to orbit. The sky above Cape Canaveral recently lit up with just such a launch, a powerful testament to the reliability and progress of commercial spaceflight. The successful launch of the Axiom 4 mission marks another milestone in the new era of access to space. A SpaceX Falcon 9 rocket, a workhorse of modern space travel, delivered its precious cargo with textbook precision. On board the Crew Dragon capsule were 4 astronauts, but this was no ordinary NASA mission. This was a private mission, organized by the company Axiom Space, carrying a crew of European astronauts to the International Space Station. It represents a new model for how nations and individuals can reach the orbiting laboratory. The crew, a mix of seasoned spaceflyers and national heroes, embarked on a multi-week stay aboard the ISS. Their mission is not for tourism or for sightseeing. They're there to work. Their schedules are packed with a demanding slate of scientific experiments, technology demonstrations, and educational outreach programs. They're using the unique microgravity environment of the station to conduct research that is impossible to perform on Earth. This mission, designated Axiom 4, underscores the growing partnership between private industry and international space agencies. Axiom Space provides the ride, the training, and the logistics, while national agencies like the European Space Agency can purchase seats for their astronauts to conduct vital research. It's a flexible and efficient model that is opening up the high frontier to more people and more science than ever before. The experiments being conducted by the Axiom 4 crew are diverse and far-reaching. They're studying how microgravity affects human biology, from cellular aging to the cardiovascular system. This research is not only crucial for enabling long-duration spaceflights to Mars and beyond, but it also has direct benefits for medicine on Earth, helping us understand osteoporosis, muscle wasting, and other age-related ailments. Beyond human health, the crew is also working on projects in material science, testing new alloys and manufacturing techniques in the vacuum of space. They're conducting experiments in fluid physics, which could lead to more efficient fuel systems or industrial processes. Each experiment is a small piece of a larger puzzle, helping us learn how to live and work sustainably off our home planet. The successful launch and docking of Axiom 4 is a powerful symbol of international collaboration. In an era of geopolitical tensions, the International Space Station remains a beacon of peaceful cooperation. Astronauts from different countries, flying on a private American rocket, working together for the shared goal of advancing human knowledge. It's a hopeful reminder of what we can achieve when we focus on our common aspirations. The reliability of the Falcon 9 and Crew Dragon system is a cornerstone of this new reality. What was once a groundbreaking and risky endeavor has become almost routine. The sight of a Falcon 9 first stage returning to Earth for a pinpoint landing is no longer a stunning surprise, but an expected part of the mission profile. This reusability is what has driven down the cost of access to space and enabled missions like Axiom 4 to flourish. Axiom Space has ambitions that go far beyond just ferrying astronauts to the ISS. Their ultimate goal is to build their own commercial space station. They're already constructing the first modules, which will initially be attached to the ISS before separating to become a free-flying, privately owned outpost in low Earth orbit. Axiom 4 is a crucial step in that plan, proving their capabilities and building the business case for a commercial future in space. This mission, therefore, represents a bridge. It's a bridge between the government-led era of the ISS and a future where commercial space stations are a thriving part of the orbital ecosystem. The astronauts of Axiom 4 are not just scientists, they're pioneers, laying the groundwork for a permanent human economy in space. As the Axiom 4 crew orbits the Earth, conducting their experiments at 17,500 miles per hour, they're carrying the torch of exploration forward. Their quiet, diligent work in the laboratory of space is just as important to our future as the dramatic tests and explosions on the ground. It is the steady, incremental progress of science that builds upon the bold leaps of engineering. The journey of Axiom 4, from the thunderous launch in Florida to the gentle docking with the ISS, is a story of success. It's a story of collaboration, of commercial innovation, and of the enduring human desire to push the boundaries of our knowledge. It's a quiet victory in our ongoing quest to make space a place not just to visit, but to live and work. Each data point they collect, each sample they analyze, is a small investment in our collective future. The successful flight of Axiom 4 is proof that the path to space is becoming wider and more accessible, allowing more minds and more ideas to contribute to the grand adventure that awaits us in the cosmos. From the patient gaze of a telescope discovering a new Earth-sized world to the bold creation of an artificial eclipse, our search for knowledge knows no limits. We see this never-ending spirit in the fiery heart of a rocket test, where failing is not the end but a lesson on the way to Mars. And we see it in the quiet teamwork of astronauts aboard the International Space Station, pushing the boundaries of science for everyone's good. These events, a mix of wins and struggles, are more than just news stories. They're important steps in the single, ongoing story of people reaching for the stars. This journey is driven by a basic human quality: curiosity. It's the same curiosity that made our ancestors cross oceans and explore new lands. Today, that ocean is the vastness of space, and our ships are the amazing machines we build to travel through it. I want you to hold on to that feeling of wonder. Keep looking up at the night sky, not just as a blanket of distant lights, but as a frontier full of mystery, possibilities, and worlds waiting to be found. Stay curious, ask questions, and follow the journey. The universe doesn't give up its secrets easily, but with each new discovery, each successful mission, and even each explosive failure, we get a little closer to understanding our place in it. The story of space exploration is our story, and it's being written every single day. Thank you for joining me on this part of the trip, for sharing in the wonder and the drive that pushes us ever onward and ever upward. The journey is far from over. This video was super epic, but if you thought this was incredible, the previous video will blow your mind. Go check it out and keep exploring with us. From Dar Space, until next time.